morning, students. I am Krishna Rao, Assistant Professor in CSE Department. I am handling the compiler design subject. So today we will discuss the front end and back end in compiler. Here we want to discuss the steps in translating the high level language programs into low level language programs. So here we use to conversion, a series of program representation will be existed. So intermediate representations optimized for program manipulations of various kinds, checking optimizations, become more machine specific and less language specific as translation proceeds. So here source code, analyzer, conceptual representation, generator synthesizer, target code. Here, the translation consists of analysis and synthesis phase. So here, the phases of a compiler, we have grouped as analyzer and synthesizer. So some phases of a compiler as analyzer, some phases of a compiler as synthesizers. So here the analyzer will be depends on the source language. Synthesizer will depends on the target code. So some phases will depends on the source program language constructs. The synthesizer will depend on the machine language constructs and its formats, right? So here simply we say the front end is the analysis phase. The front end is analysis phase. Here this analysis phase is independent of machine language. Is independent of the structure of machine language. It depends on the programming language structure. So the first one is a front end, also referred as analysis phase. Here is a main aim is it depends on the language structures and is independent of machine formats. Here it's a main task of this front end is read source program and understand its structure and meaning, and it will convert one form to another form in the compilation process. It fills the information in the symbol tables. If required, it will be handled with any errors occur. It will be handled with the error handler. Right? Next, backend. Here, the backend is a synthesis, machine dependent, and language independent. The second one is backend. This backend also referred as synthesis phase. This synthesis phase will be referred as machine dependent and language independent. It doesn't worry about the language constructs and its structures. It depends on the machine language formats. So that while it is converting the machine language, so it more depends on the machine language, right? So generate equivalent target language program. So source program, front end, back end, and target. So it must recognize the main aim of this compiler. It must recognize legal programs and it must generate error messages on illegal programs. It must generate error messages on illegal programs. It must generate correct code. It must manage storage of all the variables. It must agree with operating system and linker on target format. It must agree with operating system and linker on target format. It must agree with operating system and linker on target format. So it needs some sort of intermediate representation, right? So here it uses the intermediate representation. So the front end maps the source program into intermediate representation, intermediate machine code, right? So here the front end will convert the source program into different structures, finally into intermediate representation. Then the backend maps the intermediate representation to target machine code. Right? Is it clear? The main 2 points, front end and back end. The front end will convert the source program into intermediate representations, and the back end will convert that intermediate representations to target machine code. So here, when we need of separate front end back end, you are asked to write translators for M source languages and N target languages. How many programs you are required to, like, you have, how many programs are required? So generally, usually we say M into N complex programs. But is there any other solution? Simply we say M plus N simple programs. Instead of M into N complex programs, by using the concept of front end and back end and dividing the complex task into a simple tasks, front end and back end, simply we can convert the M into N complex programs into M plus N simple programs. Right? So here, for example, there are M source languages. There are three. The three source languages are C, Fortran, and Ada. They are M machine languages that are considered as three machine languages: x86, PowerPC, ARM. So here we want to construct a compiler for each source language to each machine language. So C is constructed, a C compiler is constructed for x86, PowerPC, ARM, right? So here we need to construct three compilers for C. Similarly, Floaton, similarly, Ada. So we need to construct 9 complex programs, right? So here a compiler is a complex source program. Constructing three different complex programs for each source language is very hard, right? So if we use the concept of front end and back end, right? So we use a common optimizer. We will construct three front ends for the source languages and three backends for the machine languages. Simply, we will connect respectively to generate a new compiler. So, for each source language, we are constructing a front end. For each backend, we'll construct a backend. So, we are mapping the respective front end and back end will result a complex compiler program. So instead of constructing 9 complex programs, now we are constructing 6 programs only we are using to generate 9 compilers. Right? We are generating the 9 compilers, but we are using the 6 programs only. Using 3 front ends and using 3 back ends, we are generating 9 different compilers for each source language and each backend machine language. So, what are the main advantages here? So, compilation is a quite complex task. Separating into a different stages, it will make it easier and helps to focus on the problem. So, it makes it easier and helps to focus on the problem. It also makes it easier to engineer and have different teams work on each part of the compiler, each phase of the compiler. Right? So here, if you want to write a single large program for this one, it's very complicated and very difficult one. So by dividing it to multiple stages, multiple simple programs, and different teams will work on each different phases of a compiler, will generate an efficient compiler. That is the first advantage of the separation of front end and back end. Then, so here the front end is specific to the source language, the back end is specific to the target machine. Here, issues related to target architecture does not need to change the front end. If any changes occurred in the source language, we need not to change the back end. So we are making the changes in the source language will not affect on the complete compiler. Just we change the simple front end or some part of the front end such that we need not to change the back end. If any changes occurred in the back end in the machine language, so we need not to change the complete compiler structure. Just we change the respective back end program such that we can use the existing compilers for modifying a simple one to generate a new compiler for new modifications, right? So that is the advantage of this front end and back end. Here, this another advantage, make it portable across languages and architectures. Right? The intermediate code is independent of source language and also the machine code. So the intermediate code, the intermediate representation is independent of the source language and machine code. Hence the compiler can easily be ported to different source language and target machines. Right? So here, if there is no change in the source program, right, simply change the backends and you can run on different machines for the same language. So it makes it portable across languages and architectures. So these are the three advantages of using a separate front end and back end. So this is a standard compiler structure. So we will have 6 phases of a compiler. What is lexical analyzer, syntax analyzer, semantic analyzer, intermediate code generator, code optimizer, code generator. These are the 6 phases of a compiler which convert the given source program to the target program, where each one will do a separate complex task and it will change one form of the source program to another form of the source program, and it will use and will be updated the symbol tables and other handlers. Now we will make as here the front end and back end. The front end is consists of the first 4 phases: the lexical analyzer, syntax analyzer, semantic analyzer, intermediate code generator. These are the 4 phases of a compiler we are considered as front end, because these are will little bit depends on the source language constructs and structure. Then the remaining 2 are code optimizer and code generator. These 2 we are saying as backend. Here these both will depend on the target machine language. So here the output of the front end The output of intermediate code generator is a intermediate machine code, intermediate representation, which is independent of front end and back end. So here it will connect the front end and back end. So by using this grouping of these phases as front end and back end, we are having multiple advantages, right? So that already we have seen, right? So this is the concept of front end back end of the compiler. So already this front end and back end is, we are grouping these phases, right, of a compiler, grouping the phases of a compiler. Here the one pass compiler, the two pass compiler, a multi pass compiler will use the front end and back end more efficiently to generate the more efficient compilers. So that is the advantage of this using front end and back end. Okay, so in this section I am closing this topic, front end and back end, and we will continue remaining in the next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.